The next speaker is Ali talked also about beautiful products, and that's what we will hear something about now. Mohammed Alshrouf, who is product and solution manager at AIKO, the company with the highest efficient solar modules in the market. We'll talk about intelligent PV power supply and storage solution. We'll talk, about residential and commercial power and why innovation, efficiency, and elegance are important. Mohammed, the floor is yours.
Thank you, Michael, and thanks everyone for joining this conference. I'm glad to take part of this event and introduce AIKO products. So let me just share my screen. So my name is Mohammed Alshrouf. I joined AIKO 2 years ago, taking care of the product and solution. I am based in Germany, and I'm mainly dedicated for North Europe. But we're also trying to keep an eye on the whole, let's say, European market. We have a solution manager dedicated for each region of Europe, and we're trying to be working closely with the installers and our partners just to know about their needs and try to get their feedback and always improve our products to meet the market requirements and expectation. So I would like to start with the most updated, upgraded products we have, which we call it the upgraded Infinite. And if we look to the power, we can see that with our Gen 3 panels, or we call it Infinite as well, we hit the 485 watts. And with the upgraded Infinite version, we will be adding 15 watts on the top of that. And you can see the difference between this new product, which will be available in the market by end of August, beginning of September this year. So you can see the gap between this power output and let's say the mainstream panels you find in the market. So it's giving us the chance to increase 30 watt more than the normal panels per panel. And to be more precise here, I'm referring to the monoglass white backsheet panel with the regular dimensions 1762 millimeter and 1134 width. Also, I would like to emphasize that this panel also based on the back contact technology. So for the guys that they don't know about AIKO, we use the back contact technology in our cells, where we managed to place the electrical circuit on the back side of the cell, and this leaves the front surface of the cell completely free to utilize 100% of the sunlight. Also, I would like to talk about the values of our products, and can be categorized in 5 groups: high power, high technology, high aesthetics, high reliability, and high returns. So we're gonna go through these groups and touch part of them. Maybe because of the time limitation, I'm not going to cover all of that. But if you are interested, you can always reach us. You can send an email. I'll try to reach, let's say the local solution manager in your region, and they will be giving you more insight about these features. So starting talking about the high power of the upgraded Infinite panels. So for the mono glass full black panels, the power will be up to 490, and widen the gap between our panels and regular panels with 30 watt. This panel also has the 2 versions, the double glass and mono glass. As you can see, this is the double glass and this is the mono glass. Also, we gonna have yeah, the dual glass white back sheet, black frame, and also the mono glass white back sheet, the black frame. So I would like also to emphasize that we have applied this upgrade only for the new Star series. These panels are based on 54 cells. So maybe in the near future, we can apply it also for the rest of our cells. But yeah, the start will be only for the new Star series. Again, these also panels has the normal features we had in our Gen 2 panels, the partial shading optimization and the temperature restriction and micro crack resistance. So all these features will be also included in the Gen 3 and the upgraded Infinite versions. Talking about the high technology, I would like to say, I would like to mention that the main idea was to reduce the non-cell area. Let's put it in this way. So by reducing the non-cell area, we could increase, let's say, the module efficiency, and by utilizing as much as we can from the front surface of the panel. So first step we have done hiding the bus ribbons on the back side, or in other words, let's say we managed to fold the string collectors on the back side. This can be done also for, let's say, the mainstream products, but there are some challenges here. This could cause a micro cracks at the edges of the cells, and also they need to leave yeah, some distance at the top of the panel in order to fold these ribbons on the back side. Luckily, we just have, the back contact circuit, and we can do all the process from the back side, which is not the case for the regular panels. The other improvement, yeah, this actually helped us to increase the power generation by, I'm talking about the first step, by 1.4 percentage. The second step we have done, we eliminated the gaps between the cells. So we basically overlapped the cells above each other. And we did the soldering again all the way from the backside. We have seen this concept in the shingle technology, but due to the fact that using adhesive material showed some issues in terms of reliability on the long term, normally after 3-5 years, it's not the conductivity of the adhesive material is going slightly down and affects the yield and the energy you can get out of the solar panels. Also for the traditional technology, can be done, but the bottleneck is the Z-shaped soldering going from the front side to the back side, again, increasing the potential of having a micro cracks. In terms of technology, I would like to also emphasize that AIKO managed to form, let's say, the tunneling oxide layers and the polycrystalline layers in completely two separate steps, which is unlikely for I would say, the rest of the solar panels. So we are leading here in this two-step processes. And this helped us to optimize the passivation for the both sides of the panels, let's say for the P and N type regions. And also this helped us to reduce the potential to have contamination that could, reduce the efficiency and the output of the solar panels. So these are the two advantages we could improve by doing these two steps processes. Also, in terms of high technology, we have a partial shading optimization feature here. Let me just play the video. Maybe the second one is enough. Let me stop this one. So here you can see that when you have, yeah, I'm talking about the right side here. When you have a dynamic shade due to chimney, how it could affect the panels. So for this case, the video is moving again. Just give me a second. Yeah, let me stop this one. Yeah, so for example, in this case, you can see how the dynamic shading affects the panels. Here on the left side is the AIKO panel, and on the right side, the regular panel. So when you have normally a shading here, for I would say the block which has a few shaded cells, the bypass diode will not get activated. But for the regular panels, when you have even one cell or half cell is shaded, the bypass diode will get activated, and this has a major impact on the energy output of the solar panels and the whole uh, the whole solar project. Sorry, the video is not working again. Let me move on. I would like also to show you the other cases. Like this is the tree shading, how also how does it affect the AIKO panels. On here you can see when you have few or part of the cells shaded, the middle bypass diode is not activated, while in the regular panel it's activated. And normally these, the panel is connected to other panels in one string, and you can imagine the impact could happen for the whole string. So more or less, let's say this partial shading optimization will help you to increase the energy output of the solar project. Here down you can see some benefits for different testing kits. This one, like row to row shading, it could help to increase the output with 7%, tree shading 12%, for the dynamic up to 50%. Talking about also high aesthetics, as I have highlighted, due to the fact that we don't have front fingers or bus bars or no cell spacing on the front side of our panels. You can see the level of blackness we could provide with, especially for the residential panels. So this is, yeah, the photos can show let's say, the difference. Another also, let's say, features, we have the high reliability of our panels. I would like to emphasize that many panels in the market, they suffer from the micro crack, and we call it the silent killer of the solar panels. And due to the fact that these panels travel all the way from China to Europe or to rest parts of the world, and they have wind and snow load. So this kind of pressure on the panel could cause this micro cracks. And in case you have a micro crack, the performance, the yield of the solar project will be reduced. So luckily we use copper instead of silver in our electrical circuit and our interconnection, and the copper has more strength compared to silver. And the other also mechanism that help us to improve the microcrack resistance, that we do the soldering all the way from the backside. Again, there's no need to go from front side to the back side, because all the electrical circuit in our cells from the back side. Talking about the high reliability, would like also to emphasize that Our panels with the monoglass version has passed the hail test of 40 millimeters hailstones. Normally, the test is taking place at speed of 25 meters per second. And also the double glass panels, they also pass the 35 millimeters hailstones. I have seen some countries asking for these tests and certificates, like Switzerland, because they have a lot of these hailstones. Maybe not the case for the rest of countries. Like, for example, in the Middle East, we don't have that much hail storms, but yeah, this could be helpful for other regions. Talking about the high reliability, also would like to emphasize that our panels has less temperature when you have a hot spot on the panel. So if you have shading for a long time affecting a certain spot of the panel, our panels will have 30% less temperature. And would like also to mention that all the double glass panels of AIKO, like Gen 2 and Gen 3 panels, they have a fire class A according to the IEC standards. So this could be a key, I would say, for some projects I have experienced in UK. They ask for this high level of fire class rating. So just keep in your mind that the double glass panels has this fire class A. Also would like to mention that some features we have in our panels could help you to increase the financial benefits of the solar system. So the temperature coefficient of our panels is minus 0.26 percentage per degree. Yeah, we have a slight advantage compared to the mainstream products. So if the product is installed in let's say south part of Europe, Spain and Italy, normally they can do more benefits compared to the projects installed in Nordics, for example. But yeah, they can still get something out of this feature. Also, we have lower degradation compared again with I'm comparing here the performance of the degradation to the mainstream products. So normally, from the second year to the 30 years, we have 0.35 percentage, and this gave us, an advantage to have 1.5 percentage more power output left in the panels compared to the mainstream. At this part, I would like to uh, just go through two cases, one for the residential segment and another case for the commercial. So the idea is that the end user, when they are using efficient panels, they can increase their financial benefits, and it's always a win-win situation for the end user to use efficient panels in their solar system. So we are just looking to a typical case study for example, here this household has two parents and two kids, and their annual energy consumption is something around 9,000 kilowatt hours.